So anyway, here I have some siltstone. This is classed as the Humevale siltstone, and it's from generally the Flowerdale area. So if you know where Flowerdale is in Victoria, you just go to Kinglake West and you just keep going north. And all in that area is the rock called the Humevale Formation, which is pretty much just the Humevale siltstone. And it's a massive to thin bedded with minor sandstone near base. And it forms hornfels when it's been metamorphized, and that's generally in Orioles, so we won't worry about talking about that. But as you can see, this is actually a massive rock. And I'm not talking about massive as in big, I'm talking about massive as it actually doesn't have any laminations. So it's just like a whole sequence, quite a large, like if you've got laminations, you're probably talking about thin. So laminations like in the sandstone, very thin. A lot of the time the laminations are not thin. And here I have here's a actual sandstone. So this is a Dargwell formation. This is also massive. It doesn't really have laminations as well. So this one has trilobite fossils. They're usually disarticulated, but that's going to be the next video. Going to do the actual sandstone. So you got laminations, and then you got massive. So it actually doesn't have any laminations. As you can see, when it actually fractures in all different directions. So the information I've found on this rock is that, so here we actually have the report for the Humevale siltstone. It's a siltstone outcrop, and this gives a lot of information about what it actually is. You can actually download this from the government website, and if you have a look, what do we want? We want the actual, so the age of the actual generally it has no fossils, have been collected around Heathcote, and I would say between Flowerdale actually no fossils as well. And if we look at the depositional environment, Humevale siltstone represents quiet water deposition in hemipelagic sediments below storm wave base. So it's in a quiet environment. That's why it's actually quite fine grained, because this is silt and clays. So when it's actually quiet waters, it will all actually is deposited because there's not enough energy to actually keep it suspended in the actual water column. Okay, grain size varies. Presence of sandstone beds indicate that some sediments were reworked by bottom currents. So you've got bottom currents. So shelf. So here we have the actual shelf. Got slope. So this is the basin. So we'd have it's described as probably being deposited in this section of a shelf, continental shelf, next to the slope or the basin, and it's the currents probably could have been coming from any direction. I'm not too sure. It doesn't actually say which direction they're actually coming from, because with lamination you can actually check which way, but this is massive, so it's a sharp base of sandstone beds on top of the formation indicate that they were deposited in sudden episodic superimposed on the more constant background deposition of siltstone. So the siltstone is deposited in quiet waters, and then sometimes they actually had like a storm or massive flood and influx of sediment, and actually because they had a lot more energy, and all of a sudden you can get transported further out to the ocean. and then when the actual energy was dissipated, it was all deposited. These beds fining upwards, so that was a slow reduction in energy, indicate deposition from extreme distal parts of turbidity current, so from a fair long way away. Okay, the lithological and sedimentary formation features of the formation and the spatial relation with the Broadwood formation indicate that it was probably deposited in distal basinwood extremity of continental shelves. So that's what I was talking about there. Distal part of the continental shelf towards the slope, and heading towards the open ocean. Okay, the turbidite deposits are interpreted as a product of storm generation density currents in the shelf environment. So it's basically what this is. It's interpreted as a shelf deposit heading closer towards the slope, and on top of this formation you actually have a sandstone on top. So this is actually pretty fine sandstone, but that sandstone has thick sand on the bottom, so large sand grains, and on the top it has fine sand grains. So we have at the start a lot of energy transporting a lot of different types of grain sizes. Then as the energy dissipated, the heavier sizes were deposited first, then slowly the medium sizes, and then the small size were deposited last. So this is a section that we actually have from another formation. So this is near the Kinglake National Park. It's not in the Kinglake National Park, so you're not actually allowed to take any rock from there. And here we have one that was described as the Killingsworth Formation. So as you can see, this is actually a different colour, but it's described as a medium bed siltstone with minor quartz sandstone. So that's all the information I can actually find on it. A lot of the other geological maps are actually excluded, so it might actually just be part of the shallow marine Humevale siltstone. So if we look at the geological map again, so what we're talking about, I actually collected these from, where's the bridge? Yeah, probably around this area. So as you can see, you got DLQ, which is the Killingsworth Formation. So the D is Devonian, the L is lower, so that's the early part, and the Q will be for Killingsworth. But this usually is included with the DIH, which is the D is the Devonian, the L is lower as with that, and H is Humevale. So I got this from around there. I got both of these rocks here from around there. That's why I reckon they're actually part of the same formation, but different coloration. So, and as you can see, this one is rounded. So this one is a river rock. It's been rounded by the action of river. So it could have been brought from another formation, but if you look at the actual, let's zoom in. Okay, the only thing about PDFs, you have to wait for them to reload because the computer's converting the pixelation. So this is actually, it could actually come from river flow. I just remember the river flow was actually in that direction, so maybe that is not it. It looks like the river flow is in that direction. So yes. So this is a bit confusing. Maybe I know it's right next to a bridge that I actually got off. But anyway, I reckon it's this. I still reckon it's here, but it could also be in this area here as well. So anyway, doesn't matter. Same formation. And the other place I actually got it from is here. We got Pheasant Creek. So this road here actually leads to the national park. You have to remember these maps are a bit old. I think this one's like 50 years old, so a lot of the roads have actually changed in a lot of areas. And here we have the Silurian. That's the Dargol formation. So that's actually a different formation. I haven't actually collected that rock here, but that's the actual Dargol formation. So you can get rocks here, and as you can see, there are some fossil formations. So there's some collected fossils on the river right here. You got a lot of fossil formations in this section. This is a strike and dip, so it's actually heading in the northwest direction. That's the dip, and this strike, so the bedding plane is northeast to southwest. So as you can see, it actually changes because this has all been folded and faulted. And if you go down this road here, there's another fossil formation there. Collected fossils. They collected fossils near the intersection of King Lake, and this goes to Flowerdale. And there's a mine, another fossil formation. So all this area actually has a lot of fossil formations. It's probably all fossil formations in this area that have not actually been surveyed. So if we go up to the north again, as you can see, I don't see any fossils that have actually been found. Looks like it's an intrusion of I didn't actually write down what that was. Oh yeah, massive quartz diorite. So that's quartz diorite intrusion. Here we have a granite diorite. That is a quartz intrusive quartz or feldspar porphyry. Need to find more information. I think that's just a granite diorite as well. And on this side we have also here, so the Devonian. So this is actually undercut by, so you got Ordovician, Silurian, Devonian. So this is younger than the actual Silurian rock. And these intrusions are also younger than the actual Devonian rock there. This should have a thin layer of aureoles around it, where the country rock has been metamorphosed. So geological maps are actually quite nice. At the start they're a bit confusing, but you actually get used to them. Just remember, this is the rock that's actually on the surface, and as you can see, there's another thin layer here. So DLF, I didn't actually write that down, so what I need to do is go over to the information. So this gives you all the information that you actually really need to know. So DLF is a Flowerdoe sandstone member, massive to thin bedded quartz and mica sandstone, lenticular conglomerate of interbedded siltstone and claystone, fossiliferous, so it has lots of fossils. So here we've got the Killingsworth formation. This is all the information I've got on it, so I actually need to look that up. So DIH siltstone, and that is basically all the information that I have on this type of siltstone. So you need to actually look at different areas. It does have fossils, but only in certain sections. Some sections have not been actually surveyed for fossils and probably wouldn't contain fossils. The areas I went to didn't have any fossils in them. Generally you'd actually find Like this one has a brachiopod. There's another brachiopod there. It looks like a coral right there. And this one also comes with trilobites as well. This one's starting to break in. Oh, no, break in half. Looks like it has a trilobite there as well. So I'm yet to actually get any fossils from this formation. I presume it probably has trilobites, crinoids. There's the actual paleontology in the age. Okay, so it contains monograptus, so it contains graptolites, ossifying Wilson Creek. Okay, so it doesn't have much information on the actual fossils that are actually found in it. So I actually need to look that up as well. Anyway, I hope this video was informative. Let me know how you think. I actually went in my first geological based video, and have an awesome, well, not coin and banknotes because that's my other channel, but fossil finding. Don't know. Anyway, I'll see you later. Thank you very much and goodbye.